What if I told you that one man changed the way humanity understands the universe? A man who was born so weak that people doubted he would survive. A child who grew up without a father. A lonely boy who spent hours staring at the sky, asking questions that nobody around him could answer. Yet that same boy would grow up to discover the laws that explain why apples fall from trees, why the moon circles the earth, and why planets travel through space. His ideas became the foundation of modern science. Without his discoveries, there would be no satellites, no space missions, no modern engineering as we know it today. But here's the most surprising part. The greatest breakthroughs of his life did not happen in a famous laboratory. They happened while he was isolated in a small village, far away from the world's greatest minds. How did a lonely child become one of the smartest people in human history? What inspired him to unlock secrets that had puzzled humanity for thousands of years? And why, more than 300 years after his death, is his name still remembered as one of the greatest geniuses of all time? This is the incredible story of the man who changed the world forever, Sir Isaac Newton. Before we begin, imagine England more than 3 centuries ago. A land of farms, horse-drawn carts, and candlelit nights. Nobody knew that in a small village called Woolsthorpe, a child had just been born who would one day reveal some of the deepest mysteries of the universe. And that extraordinary journey begins now. Isaac Newton, the man who changed the way we understand the universe. Part 1. On a cold winter day in 1642, in the small village of Woolsthorpe, England, a tiny and fragile baby was born. He was so weak that many people believed he would not survive for long. No one could have imagined that this small child would one day become one of the greatest scientists in human history. His name was Isaac Newton. Before Newton was born, his father had already passed away. As a result, he grew up without ever knowing his father. A few years later, his mother remarried and left young Isaac in the care of his grandparents. This experience had a deep impact on him. As a child, Newton often felt lonely and isolated, while other children spent their days playing games and running through the fields. He preferred to spend time alone, observing the world around him. He was fascinated by everything: the movement of clouds, the flow of water, the shadows created by sunlight, and the mechanisms inside clocks all captured his attention. He constantly asked questions and searched for answers. From an early age, Newton possessed something extraordinary: an endless curiosity. When he first attended school, he was not considered an outstanding student. In fact, many classmates paid little attention to him. But one incident changed everything. A boy at school insulted and bullied him. Hurt by the experience, Newton made a decision that would shape his future. He decided he would become the best student in the school. From that moment onward, he dedicated himself completely to learning. He studied tirelessly, spending countless hours reading and solving problems. His efforts paid off. Within a short time, Newton rose to the top of his class. Teachers began to recognize his exceptional intelligence. However, his talents extended beyond books. Newton loved building things. He created miniature mechanical devices, sundials, and even small models powered by wind. The people in his village were amazed by the inventions of the young boy. It was becoming increasingly clear that he was no ordinary child. As he grew older, his mother hoped he would become a farmer and manage the family land. But Newton's heart was elsewhere. Whenever he was sent to work in the fields, he often became distracted by books and ideas. Instead of focusing on crops and livestock, he spent his time thinking about mathematics and scientific problems. Eventually, his teachers and relatives realized that farming was not his destiny. They encouraged him to continue his education. That decision changed the course of history. In 1661, Isaac Newton entered Trinity College, Cambridge University, one of the most respected institutions in England. University life was very different from what it is today. Students often had to work while studying, and Newton's financial situation was not particularly strong. Despite these challenges, his passion for knowledge never faded. At Cambridge, a whole new world opened before him. He immersed himself in mathematics, astronomy, philosophy, and natural science. The scientific revolution was transforming Europe, and many thinkers were challenging ancient beliefs about the universe. Newton eagerly studied the work of great scholars such as Nicolaus Copernicus, Galileo Galilei, and Johannes Kepler. Their discoveries inspired him. He began to believe that nature followed precise rules and that mathematics was the language capable of explaining those rules. This idea became the foundation of his scientific thinking. While still a university student, Newton started developing revolutionary mathematical concepts. These ideas would later evolve into a powerful system known as calculus, a tool that would become essential for modern science, engineering, and technology. At the time, however, nobody knew what he was accomplishing. The world had no idea that a young student was quietly laying the groundwork for one of the greatest intellectual achievements in history. Then came a dramatic turning point. In 1665, a devastating outbreak of plague swept across England. Thousands of people died, and universities were forced to close. Cambridge shut its doors. Newton had no choice but to return to his family home in Woolsthorpe. For many students, this interruption would have been a disaster. For Newton, it became an opportunity unlike any other. During the next 2 years, he worked largely in isolation. There were no professors, no lectures, no examinations, only Newton, his thoughts, and his determination to understand the mysteries of the universe. These years would later become known as his years of wonder. In this period of solitude, he made astonishing breakthroughs that would eventually transform science forever. He devoted himself to mathematics, developed the foundations of calculus, studied the nature of light, and explored the forces governing motion. Every day brought new questions. Why do objects fall to the ground? Why does the moon orbit the Earth? Why do planets move around the sun? What exactly is light? Newton searched relentlessly for answers. One day, while sitting in the garden of his family home, he observed something simple yet profound. An apple fell from a tree. Many people have heard the famous story that the apple struck Newton on the head. Historians debate whether that actually happened. What is certain, however, is that the falling apple inspired him to think deeply about gravity. He asked himself a question that few others had considered seriously. Why does the apple always fall downward? Why doesn't it move sideways or upward? What invisible force pulls it toward the earth? The more he thought about these questions, the more extraordinary his ideas became. Perhaps the same force that pulled the apple downward was also acting on the moon. Perhaps the force extended far beyond the earth. Perhaps it reached across space itself. This simple observation led Newton toward one of the most important discoveries in human history. He began developing the theory that would eventually become the law of universal gravitation. According to this idea, every object in the universe attracts every other object through a force called gravity. The same force that causes an apple to fall also keeps the moon in orbit around the Earth and the planets in orbit around the sun. It was a breathtaking realization. For the first time, a single principle could explain both events on Earth and movements in the heavens. But Newton's journey was far from over. The discoveries he made during these years would soon revolutionize physics, astronomy, mathematics, and our understanding of reality itself. A young man working alone in a quiet English village was about to unlock secrets that had puzzled humanity for centuries, and the world would never be the same again. As the plague continued to spread across England, Isaac Newton remained in the quiet village of Woolsthorpe, far from the crowded cities and universities. To most people, those years were a time of fear and uncertainty. But for Newton, they became the most productive years of his life. While much of the country struggled to survive, Newton was busy exploring ideas that would change human history forever. Every day, he observed nature with extraordinary attention. Nothing was too small or too simple to escape his curiosity. a falling apple, a beam of sunlight, the movement of the moon. Everything seemed connected somehow, and Newton was determined to discover how. One of the biggest questions that fascinated him was motion. Why do objects move? Why do they stop? What causes them to change direction? For centuries, philosophers had debated these questions. Many believed that moving objects naturally came to rest because that was their natural state. But Newton wasn't satisfied with assumptions. He wanted proof. He wanted laws. He wanted mathematical certainty. After years of observation and calculation, he began developing principles that would later become known as the three laws of motion. These laws were simple in appearance but revolutionary in their impact. The first law stated that an object at rest remains at rest, and an object in motion remains in motion unless acted upon by an external force. Today, this idea seems obvious, but at the time, it completely changed how people understood movement. The second law explained the relationship between force, mass, and acceleration. It showed that greater force produces greater acceleration. The third law introduced another remarkable concept. For every action, there is an equal and opposite reaction. This law explains everything from walking and swimming to rockets launching into space. Together, these three laws transformed the study of mechanics. For the first time in history, scientists had a mathematical framework for understanding motion. But Newton was not finished, not even close. At the same time, he was conducting experiments with light. One day, he darkened a room and allowed a narrow beam of sunlight to pass through a small hole. The light then traveled through a glass prism. What happened next amazed him. Instead of remaining white, the light spread out into a beautiful spectrum of colors: red, orange, yellow, green, blue, indigo, violet, the colors of the rainbow. Many people believed that the prism somehow created these colors. Newton disagreed. After performing countless experiments, he reached a different conclusion. White light was not pure. It was actually made up of many different colors already. The prism merely separated them. This discovery revolutionized the science of optics. It changed the way scientists understood light forever. Newton's findings would later influence everything from photography and cameras to telescopes and modern optical technology. Yet despite these incredible discoveries, Newton rarely talked about his work. He was an intensely private person. He preferred thinking and experimenting alone rather than seeking attention. Many of his greatest ideas remained hidden in notebooks for years. When Cambridge University finally reopened, Newton returned to continue his studies. His professors quickly realized that they were dealing with an extraordinary mind. Within a relatively short period, Newton gained a reputation as one of the most brilliant scholars in England. In 1669, at only 26 years old, he was appointed Lucasian Professor of Mathematics at Cambridge. It was one of the most prestigious academic positions in the country. Remarkably, Newton was younger than many of the students he taught. As his reputation grew, so did his ambition. He continued refining his theories about gravity, motion, and mathematics. But proving his ideas would require years of additional work. He knew that extraordinary claims required extraordinary evidence. So he kept calculating, kept observing, kept questioning. The more he studied the universe, the more he became convinced that a hidden order governed everything. The same laws that controlled a falling stone also controlled the movement of planets. The same mathematics that described objects on Earth could explain events occurring millions of kilometers away in space. It was a breathtaking vision. For centuries, people had viewed Earth and the heavens as separate realms, governed by different rules. Newton believed they were governed by the same laws. If he could prove it, humanity's understanding of the universe would change forever. The challenge was enormous, but Newton had never been afraid of difficult questions. In fact, the harder the problem, the more determined he became. Little did he know that the greatest scientific work of his life was still ahead of him, a book that would revolutionize science. a masterpiece that would secure his place among the greatest thinkers in human history, a book that would eventually be known as one of the most important scientific works ever written. Its title was Philosophiae Naturalis Principia Mathematica, usually called simply the Principia, and the story of how Newton created this masterpiece is where our journey continues next. By the early 1680s, Isaac Newton had already made discoveries that could have secured his place in history. He had developed revolutionary ideas about motion. He had transformed the study of light. He had laid the foundations of calculus. Most scientists would have been satisfied with such achievements. Newton was not. Deep inside his mind, one question continued to demand an answer. What force keeps the planets moving around the sun? For years, astronomers had observed the motions of planets. The German astronomer Johannes Kepler had discovered mathematical rules describing their movements, but nobody truly understood why those movements occurred. What invisible force controlled the heavens? Newton believed he knew the answer. Gravity? The same force that pulled an apple toward the earth. The same force that caused objects to fall. The same force that acted on every object around us. Newton suspected that gravity extended far beyond Earth. He believed it reached all the way to the moon and even the distant planets. But believing something and proving it were very different things. Newton needed mathematics. Years of mathematics. One day, a scientist named Edmund Halley visited Newton. Halley was fascinated by astronomy and wanted answers about planetary motion. During their conversation, Halley asked a simple but powerful question. What kind of path would a planet follow if it were attracted to the sun by a force that decreased with distance? Newton answered almost immediately. An ellipse. Halley was shocked, not because of the answer, but because Newton had already solved the problem years earlier. Halley urged him to publish his work. At first, Newton hesitated. He disliked criticism. He disliked arguments. He preferred working alone. But Halley refused to give up. He continued encouraging Newton until finally the great scientist agreed. What followed was one of the most extraordinary periods of intellectual work in human history. Newton devoted himself almost completely to writing. Days became weeks. Weeks became months. Months became years. He worked relentlessly, sometimes forgetting meals, sometimes sleeping only a few hours. His entire focus was directed toward one goal: explaining the universe. The result was a book unlike anything the world had ever seen. Published in 1687, it carried a long Latin title, Naturalis Principia Mathematica. Today, it is simply known as the Principia. The book changed science forever. Inside its pages, Newton presented his 3 laws of motion. He explained universal gravitation. He showed how mathematics could describe the behavior of objects on Earth and in space. For the first time, the universe appeared understandable, predictable, ordered, governed by laws rather than mystery. Scientists across Europe were astonished. The book demonstrated that the same principles controlling a falling apple also controlled the moon, the planets, and even comets. The heavens and the earth were no longer separate worlds. They were part of the same system, governed by the same laws. It was one of the greatest intellectual achievements ever produced by a human being. The Principia transformed Newton into an international celebrity. His reputation spread across Europe. Kings admired him. Scientists respected him. Students studied his ideas. His influence grew rapidly, but fame brought new challenges. Newton became involved in fierce scientific disputes. One of the most famous involved calculus. A German mathematician named Gottfried Wilhelm Leibniz had independently developed a mathematical system very similar to Newton's calculus. Both men claimed priority. Supporters on both sides argued bitterly. The controversy lasted for years. It damaged friendships. It divided scientists. And it deeply affected Newton. Although historians today generally agree that both men developed calculus independently, The dispute became one of the most famous rivalries in scientific history. Yet despite these conflicts, Newton's influence continued growing. In 1696, he accepted a surprising new position. He became an official at the Royal Mint in London. The Royal Mint was responsible for producing England's coins. At the time, counterfeit money was a serious problem. Criminals were producing fake coins throughout the country. Newton approached the problem with the same determination he used in science. He investigated criminals personally. He gathered evidence. He pursued counterfeiters relentlessly. Many were arrested and prosecuted. Under Newton's leadership, England's currency became far more secure. People were surprised. How could a scientist succeed in such a practical government role? The answer was simple. Newton applied logic, discipline, and careful observation to everything he did. Whether studying planets or investigating crimes, his methods remained the same. His success at the Mint increased his public reputation even further. Then came another major honor. In 1703, Newton was elected president of the Royal Society. The Royal Society was England's most important scientific organization. Holding this position placed him at the center of British science. He would remain president for the rest of his life. Under his leadership, the society expanded its influence and prestige. Scientists from around the world looked to Newton as the leading authority on science. His opinions carried enormous weight. His discoveries shaped the future of physics, mathematics, and astronomy. But perhaps the greatest recognition came in 1705. That year, Queen Anne awarded Newton a knighthood. From that moment onward, he became known as Sir Isaac Newton. He was the first scientist to receive such an honor, primarily because of his scientific achievements. It was a remarkable moment. The lonely child who had once been left behind in a small village had become one of the most respected figures in the entire nation. Yet even with fame, wealth, and recognition, Newton never stopped thinking, never stopped questioning, never stopped searching for knowledge. And in the final years of his life, he would continue exploring some of the deepest mysteries of nature, religion, and the universe itself. But time was slowly catching up with him. The brilliant mind that had transformed humanity's understanding of reality was entering its final chapter. And that chapter would reveal a different side of the man behind the legend.